And just to confirm, can everybody hear me and see me okay? I was having a little trouble with my camera. Okay, good stuff. Okay, so last week we had 2 sessions, and in those sessions we went through Reeborg and pretty much everything that you need to finish up your Reeborg unit. We're starting our Python unit officially on Thursday. So there's a couple more days to wrap things up. I don't really have a whole lot to add to the Reeborg stuff, but I figured that I would show you maybe the beginning of 18. Some people seem to be having trouble with 18. And so I'm just going to go through the process that you should be using and that I've been recommending to everybody who's emailing me for solving these problems. A lot of the times when I get questions, I'm not provided with the algorithm that you've made for these. And I always ask for it because if you haven't made an algorithm for these later programs, say starting at about 15 to 20, you really haven't done your job in setting up your program for success and creating a blueprint that you can work through step by step to organize your thoughts, to organize your logic statements, and to create a program. So if you're just going in and trying to solve the more difficult mazes, like I said, somewhere around 14, 15 to the end, and you're just kind of hoping that you'll figure it out as you go, you've not set yourself up for success. You've set yourself up for frustration. And hopefully you're starting to realize the more of these little algorithms you make that there's a reason that I'm recommending them. And in fact, there's a reason I'm demanding them before I add more help to push you in the right direction. And that is it's an essential part of the process. There wouldn't be any reason for us to doing algorithms and flowcharts if it wasn't a necessary part of the process. So if you're feeling frustrated because you're not getting some of the later ones, it's not because you're not understanding the concepts, it's that you're not doing all of the work that you need to do in order to experience success. So it's not reasonable for you to expect to just go in and solve one without making a plan or a blueprint for it first. And if that plan's in your head and you're good enough to be able to, or if you just take to this material, your mind works in a way that you can organize these thoughts and these processes in your head without having to write it down, that's fine. But if you're not able to do that and you're not able to get the right answer without the plan, clearly you need to take a step back and create the algorithm. So I'm going to go through the recommended approach for creating an algorithm, and I think I'm going to do it on number 18. And there's a hints video, and I've tried to point people toward the hints video. The video doesn't show you how the code, it doesn't show you the code. I mean, there wouldn't be much point in that. But it does show you the way that Reeborg moves. And so when you look at those hint videos, you should be able to look at the successful solution and be able to build your own plan based on that. Okay, so what's Reeborg doing? Reeborg is finding home. And then after he's finding the flag, he's going through one row at a time and picking up carrots. And then he's recognizing when he's in the top row, and then he goes to deposit the carrots, and then he finds home again. So if you've actually watched that hint video, you should be able to build your algorithm for that step based on what you're seeing on the screen, even if you maybe had some difficulty recognizing what you need to do from the program itself. There's a hint video that shows you the process. Now, that's not the only correct process. There's many correct processes. In fact, the one I used in the video may or may not be the most efficient, but it does show you what you need to do step by step. So just give me a second here, and I'll load up 18, and I'll show you how we would do an algorithm for that. Second here. Code here. Guess it would help if I shared my screen as well. Okie dokie. Can everyone see Reeborg up there? Okay, great. All right, so one thing that I like to do when I load the programs is just start it, stop it, reload it, and just see what's happening before I even bother trying to make my algorithm. And because some mazes change, sometimes the objects change, sometimes the size of the room changes, the position of the end flag, the position of the sprite or Reeborg. And so it helps to have a kind of a good idea of the things that are changing before you even bother trying to build an algorithm. Okay, so if I look at this world and I reloaded it several times, it looks like the flag is always in the lower left corner, so that's something I noticed. It looks like the carrot dump is always in the top right corner, sort of I say bottom left corner and top right corner. So those things don't appear to change, so that's great. And then I've got carrots that I've got to pick up, and as I'm changing through this, I notice that both the position of the carrots, as well as the number of carrots in each of those positions changes. Okay, now I've also noticed that you can have carrots in any row or column except for this bottom space here and this top space here. So whatever I build, it needs to be able to go from the very left of the screen to the very right of the screen when I'm harvesting carrots, or it needs to go from the top to the bottom or the bottom to the top. So those are the things that I found that are important, and that's what I need to build my algorithm based upon. So in my mind, the easiest way to attack this one was bottom to top, because I know I need to end up at the top to dump the carrots, and then I need to go back down to the flag to end the program. But for me, it made sense to go down to the bottom of the screen first, and then to harvest the carrots moving in the left to right direction. And the reason I decided that is because the flag is down there, and the carrot dump's at the top. So I might as well work my way up to the point where I need to dump all the carrots that I picked up along the way. So in starting my algorithm, I thought that the first logical step would be find the flag. And remember, our algorithms can change. Remember, the 3 quotes allow you to put in multi-line comments, so I don't have to put that. I don't have to put the hashtag in front of everything. So find the flag. And remember, our plans can change, but we always have to have a plan. If you don't have a plan, then you're just kind of guessing. So what am I going to do after I find the flag? Well, now I'm going to find a way to harvest carrots moving left to right. So I'm going to create a harvest function, okay, moving left to right. And the reason I'm going to do that is because I'm already going to be in the lower left corner, so I might as well work my way to my right. Now, one of the problems I'm going to have to solve right off the bat is that there isn't going to be a carrot here, so that I need to make sure that I start collecting in 2 on the first row, but there is very possible that there could be a carrot in this first column. So I have to make sure that I'm not just checking the last 5 spaces. I need to be checking all 6. So I'm going to create a harvest function moving left to right. So I need to check for each spot. I need to check for carrot, and then I need to make some decisions and how many carrots are there, right? So check for a carrot, and then pick up all carrots in each spot. So I could put that as a 4th step, right? So after I check for carrots, I can pick up all the carrots in each spot, and then keep doing this until you and then you've got to keep doing this till the end of each row. Okay, and then I would you could go up. Okay, so for instance, you get to the end and Reeborg could go up and over, but I thought it was easiest just to keep the same process. So I would harvest, or my solution was harvest left to right, and then have a reset that goes up to the next row and the beginning of the next row. So in my mind, I would say create a reset function, or you can create as many functions as you want to get Reeborg to next row up, and next row up, and on the left side. And then I can keep calling that harvest function, right? Repeat harvest and reset until at top. Okay, so I need to detect how do I know I'm at the top row? Detect top row sum. And then once you've detected the top row, then you need to, sort of harvest again. And then deposit carrots at the end. All carrots at the end. Then after that, you just need to find home again. So up here when it says find the flag, I would say, build function to find. You can call it whatever you want, but maybe I'll just call it go home. So yeah, I need to run that function that I'm building for finding home at the very beginning of my program so I can get to the flag. And then at the end, you have to end up at the flag, I think. So then I would just run go home again. And then you're done. So I've created basically an 11-step algorithm for this. Remember, algorithm is just a recipe of instructions. And now I have a blueprint. Now, can that blueprint change? Of course, that blueprint can change. Maybe I get to step 5 and realize this isn't going to work, or I found a better way to do it, or whatnot. You can always change your plan. But if you don't have a plan, you're not setting yourself up for success. So if I'm able to do this stuff, and this stuff's all just written in plain English, right? If I'm able to find the flag and harvest moving left to right, and then check for carrots and pick them all up and reset to the top of the next row on the right, and somehow detect when I hit the top. If I keep going through all these instructions, I will get to number 11, and I will finish the program. So once you've created your algorithm, then it's a matter of adding in functions and adding in commands that will help you accomplish each of these. And you're not going to be able to do them all, number 1 to 11, without testing your program. There's no way. I mean, I don't think, maybe a couple students in my class might be able to start this from the top and work their way down to the bottom and do it all right the first time. But the vast, vast, vast majority of us are going to have to program a little bit, test a little bit, program a little bit, test a little bit. So, the first thing I would do is make the reset function, right? Sorry, not reset, go home function. And it's basically just finding the flag, right? So, you're going to do your def, what did I call it? Go home. Okay, so you set your function up the way you normally do. And how am I going to find home? Okay, so now this is where the harder work begins. I have a plan, but now I have to check off each of these 11 things in order to make it work properly. And again, these 11 things might be completely different for you. There's basically an infinite number of ways to do each of these programs in order to make it work. And my way is just going to be one of 20 others maybe that I see that students hand in this quint. So if yours doesn't look exactly like mine, but it gets the job done just as well, that's perfectly fine. At the end of the program, I always go back and see if I can do it more efficiently, more effectively, or so that takes the fewest number of steps to save computer resources, because that is important. But it's important to get it working first before you start tampering with it. So I'm just going to create my go home function here. Now, how am I going to detect where this flag is? And remember, I can start anywhere in the maze, so it's not assumed that I'm going to start up in this corner. I find the easiest way to find this maze is to create a loop that's going to find a wall and then follow that wall on the right until you hit go. Because as we found out from maze 17 or step 17, if you find a wall and follow it, keeping it on your right the entire time, eventually you will hit the flag no matter where it is in the maze. So the tougher part of number 17 was just creating the proper loop and logic to make sure that you follow the wall on your right. And once you figured that out, it didn't matter how big the maze was or where the flag was, you'd be able to solve it. So in this case, I'm just gonna move until I find a wall. Okay, so while front is clear, I'm just gonna move. So that's gonna get me to a wall. And then what I need to do is I need to just keep following that wall until I hit the flag. So the flag is a goal. So I think I can use a while not at goal. So as long as I'm not at the goal, it's going to keep doing these things. So while I'm not at the goal, I know I already have a wall in front of me. So how am I going to get the wall in front of me on my right? I'm going to need to turn left, right? So while I'm not at goal, I need to turn left. In fact, I don't even need to include that in my loop because that'd be kind of silly. So I'm going to turn left before I start looping. So now I'm not facing the wall. Now the wall is on my right. So how am I going to determine where, how I move until I get the flag? At this point, while you're not at the goal, if the front is clear, okay, because there's no walls in the middle of this one, so all I need to worry about is if the front is clear once I've got a wall on my right. So let's say I started over here up near the caret repository. If I find that wall, let's say I find the wall at the top and then I turn to the left, so I'm facing open space, I'm going to move as long as the front is clear. And then as soon as I hit this wall, the front is no longer clear. And if you are keeping the wall on your right, you're only ever going to have to turn left. So while you're not at the goal, if front is clear, move. And if the front's not clear, you just need to turn to the left. And that will make it clear again because you know you're in a corner. And eventually that will get you to the goal. So the first thing that I'm going to do here is test this out and make sure this works. So I'm going to just put my main code. You don't have to put this main code thing in. I'm just doing it to show you sort of how I separate my functions out from the code that calls the function. So if I run go home, let's see how my function works. First off, let's see if I made any syntax errors. Okay, no, not so far. Okay, so let's step. First step's going to be calling the go home function that I made. So it's going to go to the go home. While the front is clear, it's going to move. Okay, so he's moving. Okay, now here's the thing. Because he started right up here, he was already facing the flag, which was pretty handy. But now it's going to say, while not at goal, if front is clear, move. So theoretically, he could move this way and go an entire loop, but he's already at the goal. So he's not going to do that, right? He's at the goal, so the not isn't going to work because he is at the goal, which means this whole thing is false now. While not at goal is false because he is at the goal, okay? So he's at the goal, which means while not at goal is false, which means it's not going to run anything underneath that while statement, which means it's going to stop working right now. And of course, it gives me the error that something's wrong just because I haven't done anything in my program, but I did what I wanted to do. I got to the flag. So now I'll rerun it a bunch of times, getting Reeborg to start in different spots, getting a different maze, and see if it continues to work. So I'm just going to step through it. Okay, so I'm stepping through it. Oh, got myself a loop there. Okay, so that's a good opportunity to look at what my logic is and to see what the problem is. Okay, so once you get to a loop, you need to look at what code is highlighted and see if you can figure out why it's wrong. And that also shows the importance of testing it and reloading it, because my go home function worked the first time, but then it didn't work this second time when I reloaded it. So I might have gotten a false sense of security the first time I ran this, the test for go home, because it might have looked like it worked, but we can see that there's still some issues with it. Okay, so let's see what's going on. We are turning left. Okay, now this is the problem here. While not at goal, okay, that makes sense. Okay, because I'm currently not at the goal, so it should do what's underneath it. If the front is clear, I want to move. Well, that's great. And then I want to turn left. And I'm still not at the goal, so I'm going to move, and then I'm going to turn left. And then I'm going to move, and I'm going to turn left, I'm going to move, and I'm going to turn left, I'm going to move, etc. So I found my loop. It's right here. And the thing that's going wrong is that instead of turning left after I'm done this if statement, it needs to be an else. So while the front is clear, or if the front is clear, I'm going to move. And then if the front is not clear, that's my else statement, then I turn left. So what the problem there was, I was turning all the time, whereas I only needed to turn if this is false. I only need to turn if front is clear is false, because if front is clear is false, that means I've hit a wall. Okay, so instead of turning left every time I loop, I only want to turn left if I run into a corner. So let's see if let's test again, right? Step by step, and let's see if that's going to fix the problem. Okay, so try again. Now this time I got lucky again. I'm facing right toward the flag, so it's just going to be a quick through and through. Okay, so there he is. He found the flag. He turned to the left so that he's facing the carrots. I need to load it again to find a different starting spot. So there's a different starting spot. That should be a good one. He's facing down, which means he's going to go down. And look what happened when he hit the bottom. Okay, now it might be the most efficient for him to go back this way, but my logic is not built that way. My logic is built in such a way that he turns left when he hits a wall. Okay, so he's going to turn left. He's going to check if the front is clear. The front is not clear because there's a wall right here. So he's going to turn left again. Now the front is clear, so he's going to make his way all the way to the top. Okay, now he hit another wall, so he needs to turn left. That's the else part, right? So if front is clear, move. If the front is not clear, that means I hit a corner, so I need to turn left. And then it's just going to keep looping, right, until you're at the goal. That's what this whole loop is, while not at goal. And that's a really useful loop for all the projects from, say, step 11 all the way to the end. So hopefully you read that part where using not and a while statement is super helpful for a lot of the Reeborg stuff. Anyway, I'm still not at the goal, so I'm still going to keep doing. Check the front. Is it clear? Great, move. If it's not clear, then turn because you've hit a corner. Okay, so the front is now going to be clear. So now I'm just going to move a whole bunch. Move. Hit another corner. Okay, so now I know I need to turn left again and then move a bunch more. And I found the flag. Okay, now it doesn't look like he's turned around. Okay, but he has found the flag. Okay, so that worked in two different worlds. Why wouldn't I test it a couple more times? Again, you can just test it really quickly by reloading the world and then hitting the step-by-step and then just moving the slider. Great, he found the right spot. Test it again. Great, he found the right spot. Test it again. Great, he found the right spot. Test it again. So every time that I'm finding, the flag, I'm a little bit more convinced that, okay, this is going to work. So I've actually knocked off 2 steps of my program right now. If I look at my program, I have successfully found the flag. And if you think about it, because I need to use that again to find the home flag after I've deposited all the carrots, I've actually got rid of number 10 too. So I've actually checked 2 things off my list. All right, so you can make yourself some note that you've finished number 1, maybe by using the hashtag or something like that. I found the flag. I built a function to go home, and I know that I'm at the flag. Now, this is something that this will be a good opportunity to show you how you can change your algorithm if you recognize something along the way that's not working properly. And one thing I noticed when I was doing all my tests is, depending on where Reeborg starts, when he hits the flag, sometimes he's pointing down, and sometimes he's pointing to the left, or sorry, toward the right. He's never pointing to the left, and he's never pointing up, but sometimes he is pointing down or to the right. So I might want to test this a couple more times, because if he's always pointing the same direction when I'm done running the go home function, that's great. I'm in a good position to start building that harvest function. But if he's not facing towards the right and facing the carrots, I have to put in another check at some point to make sure that he is facing right. Okay, so I'm just going to test it a couple times. Okay, so in this one, he's facing down. In this one, he's facing down. In this one, he's facing down. In this one, facing down. Okay, so I haven't run into a situation yet where he's facing toward the right, so I'm not sure if that situation exists. Okay, I don't think it does, because anywhere I start, I'm eventually going to hit this wall and go down. I don't think there's any way. There it is. That's the way I was thinking of. He's not facing the right direction right now. So what happens when he hits the flag? He turns and he's facing down. Okay, so that's good. That was the one I was worried about, was what's going to happen if he starts here and then just goes directly to the flag from right to left, because that was the only situation I wasn't sure of. Okay, so this is good. He's always facing down when he finds the goal, but I might go up here and add in maybe 1A. Because before I do the harvest, I need to be pointing in the right direction, which is toward the right. So if I know I'm always facing down, my step 1A is after I've found the flag, I should turn and face the carrots, which means I'm going to have to turn, I'm facing down, so I'm going to have to turn to the left. Okay, so I'm changing my algorithm because I recognized something as I was building it. I recognized along the way I built my function for go home, he's always going to be facing down. So I'm going to have to deal with that. Again, this is my algorithm. Your algorithm might be different. If you build it into your go home function that he's facing the proper direction at the end of the go home function, well, that's fine. You don't need that extra step, right? But mine isn't built into there. So I need to build it in there somehow. Now I can either put it right in the go home function, or I can just put it here. It's not going to be a big deal in either case. You don't want to have Griffin. They're usually over within an hour, but sometimes they go longer, sometimes they go shorter. Okay, so I'm putting my turn left here. You want to try to keep this as clean as possible. Again, you go back and look for efficiencies later. But I don't want to throw this turn left inside my go home function right now. It's not really essential to the function. It doesn't need to be in the function. So I'm probably going to put it in my main code just to keep my function as clean as possible. So my main code currently is go home, which will run that function, and then turn left because I know that whenever I'm done running the go home function, I was facing down and I need to be facing towards the right. So now I'm just testing it a couple times, making sure it's working properly. Okay, so there we go. That one didn't look like it worked, but I just sped through it too quickly. Okay, so this one, everything looks to be working right. I've tested it like 5 times, and at the end of every test, Reeborg is exactly where Reeborg should be. Reeborg's at the flag. Reeborg is facing toward the carrots and is ready to start building, or is ready to start harvesting those carrots. So I've successfully created number 1. I've successfully done number 1A, and now I need to go on to number 2, create a harvest function moving left to right. So I, first off, should build that function. So def harvest. And what does harvest need to do? It needs to continually check and take carrots until it hits the wall. Okay, so what we need to loop, right? Every program in from 9 or 10 on needs to loop, and you need to know how to use loops in order to repeat motions, because you're never going to know the size of these larger mazes. You're never going to know how many carrots you need to pick up. It's going to be different every time, which means you have to build your program not to solve the specific problem for the step they give you, but to solve the general problem, which means you're taking into consideration all the possible positions, all the possible mazes, all the possible positions of Reeborg. If you build a program just to deal with that one specific situation, it's not a good program. It's worthless, because there could be 500 situations that are similar that your program needs to work for, and if it only works for 1 out of the 500, you've essentially wasted your time. Okay, so let's build this harvest function in a way that it doesn't matter where the carrots are, it doesn't matter how many of the carrots there are, it needs to make sure that it collects all those things. So I know that there could possibly be carrots in this first column. There isn't in the bottom row, but I have to build my function in a way that it remembers that I have to check each of these spots. And I don't know how many of these columns they're going to be. Right now I've got 5 of them, but the next time I load it, there might be 2. So there might be 2 columns, and it's not going to let me test it because I started a function that I haven't used. Okay, so now it's a narrow. It's I've got 3 columns instead of 5 or whatever I had before, and every time I reload it, it's going to be different, both the number of columns and the number of rows there are. So I need to remember that and keep that in my mind as I'm building this next step. So I'm just going to get to a slightly bigger maze. Okay, so now I know I'm going to be here, and I'm going to be facing toward the right, and I also know that I need to check every spot until I hit a wall. So the until I hit a wall part, because that's how I'm going to know I'm at the end of each row, is very important. Until I hit a wall. Well, every time you say the word until, you should be thinking, well, that's a while statement, right? Because I don't know how many times I'm going to have to move. It could be 2 times, it could be 10 times, I don't know. All I do know is when I get to the end, there's going to be a wall there. So that's what you use to build your looping logic. So in your def, your function for harvest, your first instinct should be, because I don't know how long it is, I need to have some sort of while statement in there. So in this case, while, what, until what? It was until I find a wall. So while the front is clear is how I would probably set that up. But you could also do while not wall in front. You can see how there's different ways to do it, right? While front is clear is going to keep going until I hit a wall. But if I did something while not wall in front or something, that does the exact same thing. It's just does it using the opposite logic. Instead of me moving as long as the front is clear, I'm going to move as long as the front is not blocked. I mean, it really means the same thing, but it's written 2 different ways. So you can use the not keyword very effectively if you want to, and it comes into play a lot of time in this for the not at goal, because now I can, if I put a not while at goal, not a while not at goal in my program, I know it's going to keep doing whatever it is I want it to do until Reeborg hits the goal. So that's just a really simple loop for me to put in to guarantee that it's going to keep looping until he gets to the goal space. Now, in this case, that's not the only thing we need to do, because getting him to the goal before he does all the harvesting doesn't finish the program. It just helps us get started. But the point was, you need to be able to use whiles. You need to be able to understand how to loop and use whiles, especially when you don't know how many times you have to do something. That's what a while's for. If you know how many times you need to do something, you use a repeat. For instance, if this world was always 6 by 6, I would use a repeat 6, because it's never going to get any bigger and it's never going to get any smaller, so I don't need a while. I might use a while because I might find it, more efficient or elegant, but if I know the size of the maze every time, I might as well just use a repeat because it's never going to change. This one's going to change. That's why we have to do this. So I'm going to use the simpler of the 2 logic statements. I'm going to say while the front is clear. Okay, what do I need to do? I need to check for carrots, and then I need to collect carrots, and then I need to move. So if you wanted to make your your algorithm, sort of more efficient or effective, I would say create a harvest function, and then I would put maybe 2A and 2B, etc., because these are all really kind of part of step number 2. Okay, so in order to complete step number 2, I need to do all of these things, right? I need to check for carrots. I need to pick up carrots in each spot, all of them, not just one. And then I need to keep doing that to the end of the row. So really, what I said, step 2, 3, 4, and 5, those are really step 2A, 2B, 2C, because it's all part of what we're trying to accomplish there with that second bullet point. So this might be a better way for me to number my steps. So in creating a harvest, I need to check for a carrot first. So I know how to do that. That's easy. So if object here, you don't have to specify what kind of object it is. Some people were doing this, or carrot. Some people were doing this, it'll work perfectly fine, but you don't need to. If object here, we'll check if any object's there. So it doesn't matter that it's carrot or dandelion or a star or something like that. So you don't have to actually put those specific object names in, although it will work if you do it as well. So if there's an object here, what do I want to do? Okay, now, if there was only 1 carrot, I would just pick up a carrot and move. But I don't know how many carrots there are, which means I need another while statement, and I need to pick up all the carrots as long as there is a carrot there. So what I might want to do here instead of an if statement is use a while statement, which actually includes some logic. So while, okay, so I could do this with an if statement, an if, and then a while inside the if statement, but it might be easier just to use the while. While object here, I want to take that object. Okay, one can do this without an if statement because it's only going to do this chunk while there's an object there. So if there is no object there, it's just going to ignore this whole thing, and that's fine by me. Because if there's no carrots there, I don't need to do anything. So at that point, I can just move. Okay. So while the front is clear, I'll just zoom in on this a bit here. While the front is clear, okay, my first step is going to be, while there's an object here, take it. So if there's objects there, it's just going to keep taking them until it picked all the carrots. If there's no object here, this is false, right? While object here is false. Now, while statements have true and false options, just like if statements, right? While front is clear can either be true or false. It can't be both. It has to be one or the other. While there's an object here, has to be true or false. It can't be, the object can't both be there and not be there, right? This is the whole basis of computer science and binary. It has to be one thing or the other. So I checked if the front is clear, and let's say that is false, or true, sorry. So I know I'm not at the wall yet. Then I move into the next step, and now I check, is there an object here? Okay, using a while statement, while object here. Well, that's either true or false. Either there's an object there, and I need to take it, and keep taking it until they're all gone, or that's false, and then it just skips over to the next step, which is move. Because I know that if I've taken all of the carrots from a certain spot, I'm done there. I'm still facing the proper direction, okay, which means I can move now. Okay, so I think I'm going to run into a little bit of it. I just noticed a little logic error, but I'm going to let it happen. I'm going to have a little bit of a logic error because if I'm moving before I'm checking that the front is clear, I might run right into a wall. Okay, but we'll see if this works when I run it. So I think I've finished taking care of 2A. I've checked for carrots using the while. I'm picking up the carrots in the while, and I'm going to keep doing this till the end of the row. That's the while front is clear. So every time I move, I'm going to check the next spot and then get all the carrots, and then the next spot, and then the next spot, and then the next spot. And the only thing that might be a problem is this move at the end. So we'll see what happens there. Okay. We're going to step. We know our guy's going to find home first, so he's going to go find home. Okay. So now Reeborg has found home, has turned left, and then why did my program end? Oh, because I didn't actually run harvest. So I need to remember, it's not enough just to create the function. You actually have to call it and run it. I forgot to call it. So here we go. So let's get home. Okay, let's face the right direction. Okay, now you see we're done finding home. So we turned left, and now we're on the harvest part. So now it's going to run this harvest part. There's no carrots, okay, here, so he's got to move. There's no carrots, got to move, got to move, got to move, got to move. Okay, now we finally got the carrots, okay? Now, while the front is clear, I need to check for carrots. Now, here's the problem in the logic the logic error that I spotted before, and I let it happen. Here's the problem: is while the front is clear, he's going to harvest. I'm in the last position, and I need to harvest, but I basically told it only harvest if the front is clear. The front is not clear on this one, which means he's never actually going to go and do that harvest. So right away, the program presented me with a situation where I'm in trouble because I didn't build my harvest function in such a way that it's going to handle the carrots that are right up against the wall. So if I reload this, you're going to notice that I'm going to be able to get the carrots here and here. So I'm going to be able to get the 1 and the 3, but I'm not going to be able to get the 2, and that's causing me a problem. Okay, so if I keep stepping through, okay, while front is clear, that's true. So it means it will get to the next line, which is while object here. Okay, well, that's true because there's a carrot there. So it's going to take the carrot, okay, and then it's going to move because this while is done because there was only 1 carrot there. So it's going to keep moving. Now it's going to get to the one that's got 3 carrots. So now it's going to, while object here, take. Okay, so there's 1 object there, take it. Now there's another object, take it. Now there's another object, take it. Now we're out of objects and it's time to move again. And then this is where the problem comes in, is because I've moved into a position where the front is not clear, now I've not been able to pick up those carrots in the last position. So whenever you get into a position like that, you basically have to go back to your code, because the last thing that the code executed is going to be where your problem is. So that's why when you're testing it, if you run into a problem, you check over here and say, well, what line of code am I on? Because that's the line that I'm going to have to do a work with. Now, this might not be the most elegant solution, but I'm going to make it work, and then I'm going to see if I can make it work better. Okay, so the problem is when I get to this move statement, okay, I need to check after I move. Okay, I need to check after I move to see if I'm at the wall again, because if I'm at the wall with that last move, I need to harvest the carrots again. So this might not be the most elegant solution, but I know where the problem is in my code, and I know how I can fix it to kind of band-aid it for now. And then likely later I would go back and see, I think my harvest function is a little too long. It checks too many things. There's probably a better way for me to organize it, but I want to make it work first. So instead of just moving, okay, if after I move, I need to check, am I at the wall? Okay, so let's check again. I know we've got something up here checking if the front is clear, but we're going to check again. And remember, you can put as many of these things inside other containers as you want. You can have as many while statements inside other while statements. You can have ifs inside ifs. You can have ifs inside of whiles. It's called nesting. You can put as many of these structures in as you want, but you want to do it in the most effective way. So let's get it working, and then when I'm done the program, I would definitely go back and look at this again. Okay, so this is where my problem is. So right after I move, I'm going to check and see if I'm at the wall again. So if front, okay, so if front is clear, okay, if the front is clear, that means, sorry, I should check if front is blocked. I can't remember the exact code for it. Where's my conditions? If wall in front, that's what it was, sorry. So I'm going to check if there's a wall in front. So if wall in front, and I could have used if not front is clear. If wall in front, okay, if there's a wall in front on this one after I've moved, it means I must be in this last position. So if I'm in this last position, I know I need to collect the carrots again. And I already know how to collect carrots, right? It's just the while object here, take. Okay, so I'm just going to repeat that step, except I'm putting it inside the if statement. Now, I don't need an else for this one. Make sure you've got everything lined up properly. I don't need an else for this one, because the only thing I need to check is, am I at the last position? Because if I'm at the last position, it's not going to run this again because the front is clear, or is not clear. So it's okay that I've got two separate kind of checks for wall in front, because this one, the bottom one, is only going to run if I'm at the very end of my loop here. So so just watch how it happens, and we'll step through it. So again, this is probably not the most elegant solution, but I could probably reorganize this or use slightly different logic to make it still work properly with fewer lines of code. But I always want to get things working first before I start playing with it too much. Okay, so anyway, let's see what happens. All right, so we get to home. We face right. Now let's see what's happening. We know that we can collect carrots all the way across. That was already working, so I'm just going to skip through that. The problem was when I get to the end. Now there's no carrots at the end of this one, okay, but I want to see if it breaks. Okay, so it didn't break. It just said I'm not in the right position. I'm going to reload it until I find something with carrots there. Okay, perfect, right there. Okay, now let's see if it collects those last 3 carrots, because that's where our problem has been. Okay, so step to the last set of carrots. Now, as I step to the last set of carrots, remember, it's checking this second time if there's a wall in front. Is there a wall in front? Well, that should be true. There is a wall in front. So while there's an object there, I'm going to take that object. So here I go. I'm going to take those 3 carrots. And now, because I took all the carrots, now this while statement is done. I already did this if statement, which means it goes back to the front check. And the front check is while front is clear, which is now false because I am facing a wall, so the front is not clear, which means my program's going to end right now. But it didn't break. It did exactly what I wanted it to do. He found the flag. Okay? He harvested carrots all the way from the left to the right, and then we made sure that he got all the carrots in that last row. So that checks off all of these. Okay, we created a harvest. We checked for carrots. We picked up all the carrots in each spot. We kept doing this till we hit the end of the row. And we actually did one more thing. Okay, we actually did one more thing that I didn't log up here, and that was, make sure you get carrots in last spot, because the first time I built that harvest, he didn't pick up the carrots in this last spot, so I had to put in this little step right here to make sure that that happened, which is that little chunk there. Okay, so great. So I've checked off number 2. Now I go to number 3, which is pretty simple. I called it reset. You can call it whatever you want. And the whole point of reset is to know that you're at the end of a row facing a wall. The wall is in front of you, and you're on the far right side. And all reset needs to do is find a way to make Reeborg go up to the second row and then face right. Because as soon as Reeborg's in the second row facing right, you can run the harvest function again. And we'll worry about the bigger loop as to how many times you have to run that harvest function later. But we know that after we reset, we should be facing the right direction in a new row with new carrots, and then we can run harvest again. So I'm not going to take you any further than that because that's already quite a really good chunk of the program. But the whole point of this is if you're not doing an algorithm and you're not going through it step by step, you can't expect to be able to solve these. And the same thing goes in Python. Okay, some students skip the algorithm because they think they can just sort of bounce their way through it. Some students skip it because they're just lazy and don't want to do it. And some people aren't, maybe didn't believe yet that I actually need to do this in order to make my program successful. And again, that's the whole reason we do it. I wouldn't tell you or advise that you do something or teach you how to do something like an algorithm or a flowchart if it wasn't an important part of the process and part of your job as a student, and it is. So I'm always here for help, and I want to continue to offer help via email in these sessions and whatnot. But if I ask you for your algorithm before I point you in the right direction, I expect that you've got an algorithm, because if you haven't, you just literally haven't done the first step of the project, and you don't need help yet. You need to do your algorithm. And if there's problems with the algorithm, well, certainly then you can ask for help there. But I think most of the time, in plain English, you can explain what you think Reeborg needs to do in all these. Okay, so that's about, I guess that's about 40, 45 minutes. That's all I had for today. I don't want to start into Python yet. Some students have moved into Python because they ripped through Reeborg, and that's fine, no problem with that. Some students won't start Python until Thursday, and that's fine as well. But you should be getting near the end of Reeborg. If you're not in the last, say step 16 to 20 in Reeborg, you need to consider that you're quite a bit behind, okay? And you need to get caught up, because as I've been saying the entire time, once you hit Module 4 in Python, things come very quickly until the end of the class. And if you don't have a solid understanding of these concepts through Reeborg, it's going to be really difficult for you to get through it and to earn a credit in the course. So this is the time where if you haven't maybe been putting in the 2.5 hours per day, you're going to need to decide right away. Am I going to keep doing this class? Am I going to put that time in? Am I going to catch up? Am I going to ask for help? Am I going to watch the videos and learn? Or am I, is it not going well? Am I not willing to do this? Do I have other priorities or things going on in my life? Which, I understand. We all understand. But if you are, a week or 2 weeks behind, this is the point in the semester or in the quint that you really have to decide what you're willing to do. Because if you leave it later than this, there's just no way you can possibly get caught up. So this is going to be an important week for several people. And as always, this is just factual information. So if you have any questions about that, please email me. If you're struggling with something, please email me. And I'm going to do my best to help you out. So I'm just going to check the chat here, see if there's any outstanding questions. I don't think there is. Okay. So it was a long weekend. So I've got a lot of stuff that people have done, from Friday till Sunday. So if you've handed something in on the long weekend, it's sitting there in my inbox, and I've got to find time today and tomorrow to make sure I mark all those things and get them back to you, so you have feedback to keep moving forward. And good luck to you. Keep doing the things you're doing well, and keep working hard. Embrace some of that frustration, because it's going to pay out in the end when you get the right solution. And I'll open it up to any questions. I might stop the recording now, but I'll open it up to any questions that people have.